Parts of a microcontroller. The first part is the CPU, or Central Processing Unit. Central Processing Unit is the brain of the microcontroller, and it is used to process data according to the program that is uploaded. Okay, along with general arithmetic and logic capabilities, okay, the algorithmic, those are aspects like addition, subtraction, multiplication, division, and then your logic functions, that's like your AND, your OR, and your NOT functions, like was done in grade 10 and 11. The CPU also has additional controls over components to ensure that the program is run in the correct sequence. And finally, the CPU is mounted with specific registers, as can be seen in the block diagram. The registers are divided into data registers, these are the registers that actually stores the ones and the zeros that make up the information. Then we've got the address registers. These registers actually stores the position of the data that has been stored by the data register. So this is the information, and the address register keeps track of what information is actually stored where. Then there's the general purpose registers, which can be used to either store data or addresses. As is required. And then finally we have got floating point registers. That has the ability to store integers, which is primarily used for analog values. The next part of the microcontroller is the memory, which is divided into RAM and ROM. The RAM is the random access memory, and this is what is being stored by the registers. It's temporary and store data for calculation and communication. The ROM, read only memory, functions to store instructions or program, that is used to tell the CPU how to operate. Types of ROM are the EEPROM, that's the erasable programmable read-only memory. That can be erased by means of UV light and then reprogrammed electronically. Second type is the EEPROM. That is the electronically erasable programmable read-only memory. It can be reprogrammed, deleted electronically and reprogrammed electronically. And then finally is your flash ROM, which is similar to the EEPROM. It is faster to reprogram. EEPROM has a shorter lifespan compared to the EEPROM and the EEPROM. Then we've got input and output pins. The input and the output. These both work on the concept of 5 volts. Depending on the make and model, typically we've got 5 volts. So 5 volts will read as a logic 1 and 0 volts will read as a logic 0 for both the input and the output pins. The inputs are used to gather information from real life components and real life conditions, and the output is used to control devices in accordance with the program that has been used. Finally, we're looking at timers and analog to digital converters. Timers are simple. Their function is to primarily keep track of time. In essence, they are used in timers, clocking, the running of the registers, and data transfer between the different ports in the PLC inside the microcontroller. The analog to digital converter, how that one functions is it takes your input, which ranges from 0 volts to 5 volts. That range is then divided into 255 pieces. In other words, if we were to say 5 volts and divide it into 255 pieces, we will see that 1 volt is equal to 51 of those pieces that we've got over there. So by looking at the voltage that's being measured, we can see that we've got a set ratio between what the voltage and what the value is going to be. So this is how we can then see what the actual value is, and then in our program we're just going to need to put in a step to say this is what I'm expecting on the input, that is my cutoff, everything above that I'm considering as a logic 1, everything below that I'm considering as a logic 0.